We represent the MITRE team. For those of you that don't know, MITRE is a federally funded we operate federally funded research and development centers on behalf of the federal government. In addition to the work we do directly with federal agencies, we run an independent research and development program, which is trying to look at the next set of challenges government's going to face. What you're going to hear about today is some of the work we're doing on one of those independent research projects. Much of what you've seen today from the different demos are people looking at using AI to interact and get answers out of a huge corpus of policy information that exists. That corpus of information was written by humans for humans. It's complex, it gets amended with every piece of legislation, and some agencies, that corpus of knowledge, when you get the policy, the supporting court cases, the legislation that enumerated, memos for better understanding internally, can approach millions of pages of documentation. That's a lot of content to interact with, and it presents a lot of the challenges that we're seeing with the RAG models, the LLMs, as they try to navigate all of that. So our thought was, as we look at the federal governments that use these policies to adjudicate benefits on behalf of citizens, veterans, et cetera, we wanted to take a look at, is there a different way? Is there a way to create computable policy that becomes the source code by which LLMs interact, case management systems interact, chatbots interact? Is there a better way to communicate that knowledge? So the research we did was twofold. The first thing we wanted to do is start to take LLMs, take a look at a large corpus of policy, and start to evaluate it with metrics. As you can tell, the supply chain for how policy is created is very complicated. The resulting product, when you have different lines of business at an agency, different legal experts and policy experts writing, you get a lot of variability on this policy. And so the first area of research that we did was taking a look at LLMs and coming up with a set of metrics to help us understand readability, complexity, legal alignment. These are important things to understand the policy set you're working with. The second work stream that we took on is, once you have a corpus of policy, go down into specific policies and have the machines help us translate that into a machine-readable, computable set of code that can then be consumed by lines of business, various systems, chatbots internally, chatbots externally, et cetera. I want to make sure we stay on time here. So the most notable part about the computation or the digestion of the corpus of knowledge was thinking about the metadata. So when you have a large corpus of policy information, breaking that up and processing it so then the machines can then take the individual policy sets, the questions, the specific answers that are being asked, and translate that into the computer code. I'm going to introduce Jackie to walk us through some of our results and some of the insights that we found.
Thank you. So in terms of results to date for our research, our policy complexity analysis highlighted some interesting findings, notably the different types of relationships but to other policies and legal resources. So the graph below here to the right just captures a brief snapshot of the relationship, the linkages that we found between these legislations, manuals, etc. So at first glance, the linkages appear to have more of a simple star network, but upon further analysis, we found a more complex structure. And these relationships must be interpreted for any analysis on a policy's complexity, especially as we consider the dynamic legislative landscape, timelines, and so on. But we also did a bit of work on translating a policy decision process to verifiable and executable decision model notation, or DMN, rules. And as Matt alluded to, we believe that these rules are pivotal in streamlining policy implementation. So we started with a manual translation, both to understand what we would try to reproduce at a larger scale, and then to also give our LLM something to learn from. And then after verification with subject matter experts, we proceeded with the automation. An interesting outproduct of our automation work is our process to break down the step logic for making a decision as dictated by the policy rules. And a flow that we found that worked well and that we'll just continue to refine as we go forward is to take the policy, prompt the LLM to interpret its general idea or the policy decision logic, chunk this logic into more discrete steps or a decision tree, and then convert these steps into a series of connected DMN tables before finally converting it to XML for verification in our DMN simulator tool. So this flow not only got us closer to producing these computable rules, but it's also advantageous in the fact that at multiple steps in this process, a domain expert can go in and verify this translation to ensure that the LLM didn't oversimplify any rules and that all the details are appropriately captured. And then, so lastly, to evaluate our work, we generated these personae just to compare the automatically and manually generated rules. And by making this a diversity of these personae and checking where the rules differ and in their decision evaluations, we aim to stress test these rules to overcome any rare but possible edge cases and to develop intuition of how our automation can and should be improved. Insights-wise, we found that while LLMs can be used to generate the DMN notation, we still need a human to define the meta model of what decision we're actually asking of this policy text, and so basically what questions are being asked of the policy, and how must that question, as understandable as it is to a human being, be asked of an LLM in a way that makes explicit the things that we humans understand implicitly. We also found that different LLMs do have varying strengths and weaknesses, whether that's in getting the DMN note syntax right or interpreting the relationship between different entities properly from the policy text. So for this, we would like to fine-tune a model for policy, and that would then be best suited for generating these rules. And then finally, like with many other projects here, we found that context is critical in translating these policies into rules. So we do need to determine a way to identify what context to include and exclude. So definitely suffice to say, a lot of interesting questions to continue to explore, but from our work so far, we're really optimistic and excited for where our project's going. So feel free to follow up with our team here at MITRE, and we'll be happy to continue the conversation. Thank you.